Hey man, what are you doing?
Drawing a shark.
Why are you drawing a shark?
Shark Week.
It's not Shark Week.
Yes, it is.
No, Shark Week's like 6 months away.
Yeah, I know. It's exactly 5 months, 14 days, 3 hours, and 2 minutes.
Why do you know that?
Shark Week.
Just Shark Week?
Shark Week.
Shark Week. Shark Week.
Shark Week. Okay. Shark Week is like a limit. The limit of 1 over I as I approaches Shark Week from the left because you can't go backwards in time. I is on the interval 0 to 5 months, 14 days, 3 hours, and 1 minute. Now, as you can see from the graph, after Shark Week, time's flowing pretty fast. You know what I'm saying? Like, it feels that way. And then as Shark Week's distance, as we gain distance towards the next Shark Week, it begins to slow down. And as we get closer to Shark Week, time slows down even more. Until it feels eventually like we're going so slow that we may never reach Shark Week. Like a limit. Go right infinitesimally towards the point that is there. See what it is. 2 hours and 59 minutes.
Oh, so that's what a limit's for. Makes sense.
$58
Okay, so this is the equation for how high a shark can jump. Just like that, yeah. So we're going to use calculus to find this out. We're going to use what's called a derivative. Crazy, I know. So to take a derivative, you take the 9, which is a constant. Constants don't have a slope. So you're going to change that to 0. And you're going to subtract from this. You're going to multiply the exponent to the front. Keep what's on the inside using the product rule, and then multiply by what's on the inside. Now you would lower that to 1. You lower that by 1 exponent, which becomes 1, which does not change anything. So you'd be using the function d inner, d outer, which winds up giving you -2 x minus 3. This gives you the velocity function, because velocity is a derivative of height and position.
Look what we did! Here at Atomic Products, we ask, what is it better when you strap uranium to it? Turns out, sharks. Atomic Products is not responsible for any attacks by giant mutant sharks.
So here we have the graph of a shark jumping out of the water. There he jumps out of the water and that's where he lands. This is the velocity of him. As he jumps, when he first jumps out, he's moving really fast. And he begins to slow down as he moves through the air. At this point, he actually stops moving because he's at the maximum of his height and begins to move back towards the water, which is why it moves into the negatives. How did you draw all this so fast? We're only going for like 30 seconds.
I'm not really sure.
What are you guys doing?
Shark Week.
Shark Week.
Shark Week?
Shark Week.
Shark Week! So, from that video you guys were watching of the shark swimming, I discovered that its velocity is this formula right here. So I figured we could probably find out the formula, how far it's traveled over a certain time, with x being time, by taking the integral of this formula. For the sake of time, we've already predetermined the integral of this equation right here. which happens to be the position function. So if we take the integral on 0 to 15 seconds, because we're taking it from when the shark started moving to when the shark, 15 seconds after he started, of v of x dx, to take the integral of this equation here. It ends up with this, except it would be on 15 to 0, which means you plug in a 15 for these x's, and then subtract it with a minus, and then plug in zeros for those x's. And since c is going to be c minus c, it cancels out. Okay? Shark week. Okay, so using the calculator to find this, by plugging in, making the graph of the equation, and then looking at it, typing in second trace, you take the integral of it on 0 to 15, and it ends up being 289.6 meters.
Shark Week! Shark Week! I got Shark Week on DVD. It's always Shark Week. Shark Week. Shark Week. Shark Week.